Alright, welcome back to the 6th video covering deep learning library. In previous video, we had already tested our library on different classification and regression tests, and it was working fine. So right now we have a general standard implementation of gradient descent as our first optimization algorithm. In this video, we are going to be adding support for Xavier's initialization as well as L2 regularization. So first of all, let's add support for Xavier's initialization. So we'll change this function called initialize parameters. So first of all, what is Xavier's initialization? Well, it was a research paper introduced a few years back which states that instead of just randomly initializing the parameters of the layer, if we multiply that by a particular constant and that constant varies layer to layer, the training is much smoother, much faster, right? So what is that constant? It is 2 divided by the layer parameters of previous layer, the whole under root, right? So we need to multiply this by that value and not by this 0.01. So let me just multiply that and to the sqrt and 2 divided by 2 divided by layer dimensions of previous layer I minus 1. So this is that. And yeah, that's it. Let me just add this multiplication sign. And let's run the test.py for this. So let's just copy path and go to terminal and Python 3 paste. Well, let me just change the seed to 3 anyway. Let's wait for this to execute. So it has executed, and if you will compare this execution to the previous execution without Xavier's initialization, you'll see that this cost function is much lower, so which means that the network is converging much faster. So that's working fine. Now let's add support for regularization. So for that, we will first make a new class variable self.lamp, which will be the regularization parameter, and set it to 0. And well, we will also add a regularization parameter in gradient descent. So we will add lamp equal to none, or let's just say equal to none. Now let's also add a regularization cost and set that equal to 0 for now. And well, let's just check here if the user has provided us with some value. If lamp is not equal to none, then we can in L2 regularization we are going to be adding support for L2 regularization. So in that, what we do is we just square all the parameters except the bias parameters and add all of them together. So let's run a loop through all the parameters. So for params in range length of self.cache, so if the length of cache is 2, it will run from 0 to 1. So there's that, and we can just quickly add all that. So regularization cost plus self.parameters capital W plus str params plus 1. And finally, let's just divide this entire regularization cost by, first let's multiply this by lambda and then divide it by 2 into input dot shape, number of inputs basically, into regularization cost. Why we are doing that? Because it's easy to calculate derivative. So as you can already see, when we had calculated this cost across entropy loss, we had divided this divided the loss by 1 by predictions dot shape, and which basically means that we are dividing the entire loss by the number of training examples. So it's very easy to calculate the backpropagation. So where it is, now let's just set loss equal to the loss plus the regularization cost. And now let's say self.lamb. Now we know that the user has provided us with lambda value, so we will set that equal to the lamb. Now the only thing that will change here is while calculating linear backward, and the DW will change. So if you're familiar with calculus and the calculus involved in the calculation of gradient descent, you can just verify this easily. So well, we have added the squares of each layer parameter, so derivative of square is 2 times that value, but we have already divided it by 2 here, which means we just have to add the lambda divided by that lambda into that value. So well, where is that layer? Yeah, here it is. So only DW will change, and as you can see, I've already started adding it. So self.lamb times divided by batch size, as we have already added, because it's a constant, and we had divided it by batch size during the calculation of the cost. So we are supposed to multiply that or divide it by that right now. So now self.parameters and w plus str and n layer. Yeah, that's it. Now let's just try to run this again. I guess I've not missed anything. Yeah, so let me just try to run this test function again. First, without regularization, as we have already run it here. So let me see if there are any errors. So yeah, there is no error, and as you can already see the last loss, you can compare that last loss and the accuracy of the classification test to the previous run. These are both the same, right? Which means the network is working fine. Now let's add regularization to both the networks. So well, let me just say let's set lamb equal to 0.01 here, and let's say you want to regularize this by a factor of 0.05. Okay, so we are regularizing classification by 0.01 and regression by 0.05, right? And name param is not defined. Where the hell it is? Okay, let me just check it here. We have got an error here, and for params, okay, so I have added params, or let's say that's right, and yeah, all right. Regulation cost, let me just check this. Self.parameters param plus 1 operator not broadcast values. All right. Okay, let me just find the error. I'm gonna pause the video, and when I find the error, I'll tell you that. So it's very obvious. I already stated that during regularization, L2 regularization, we need to add the sum of square of parameters, and I have done neither of those things here. So np.sum and np.square, and let's add just 2 parentheses here, and I guess we should be fine now. Yeah, so well, let me just run this. Yeah, so as you can see, we have got the same accuracy, of course, but there will be slight difference in the cost functions, so which means that we have already added the regularization parameters, and you can just add and use it according to your own preferences. So yeah, there's that, and that's it for this video. I guess in the next video I'm going to be adding Adam or momentum or some advanced optimization algorithms, and I'm not sure what. So yeah, just stay tuned. Alright, and if you want to contribute, just go ahead and contribute to the GitHub link in the description, and yeah, that's it. Goodbye.